COMSOL Multiphysics Lecture 4, Generating a COMSOL app. In SolidWorks environment, open the part file. Choose XY plane, enter sketch mode, draw a rectangle. Place the dimension 50 by 50 and extruded section into 1 meter long. Save the file on desktop. And in order to transfer the dimensional parameters onto COMSOL, we need to display the dimensions and make sure that the COMSOL live link is toggled on. And in order to transfer dimensional parameter onto COMSOL, we need to choose parameter selection and choose these dimension parameters and add them to COMSOL. So these dimensions will transfer to COMSOL. Now we can enter COMSOL environment and start a 3D problem. SolidWorks, solid mechanics problem, and statics problem. And we'll import the geometry from SolidWorks by live link and clicking synchronize, and we will import the geometry here. So we have finished with the first step, but make sure that these parameters are linked to SolidWorks. And actually, this is where the parameters are defined. So if you want to change the name of the parameters, you need to change it here, not here, because this is the global definition of the parameters. So I'll add other parameters such as Young's modulus, and which is 3 times 10 to the 11th Pascal or Newton per meter square. And for Poisson's ratio, nu is 0.3. And in COMSOL, it is required that density is entered in a static problem. So I'll define the density, which is kilogram per meter cube, and this is shift 6. And also I'll define force of 100 Newton. So now these are my parameters. So after finish with the first step, I'll go ahead and define material, which is the second step. I'll open a blank material and enter Young's modulus, Poisson's ratio, and density. Make sure that material property will be connected to geometry. So I finished with the second step. For the third step, I'll choose extra fine and build the mesh. Step 4, boundary conditions and loading. I'll fix the right end and apply a load, boundary load, on the left surface. The type of the force will be concentrated force. Type of the force, area or surface of loading. Direction of the force is y direction, and the magnitude is minus FF, which is a parameter here, right? So this is the boundary load. So I have finished with the 4 steps in CAE analysis. So I finish with preprocessors and I'll calculate. And this is the step 5. And after finish calculating, we'll enter step 6, which is the result part. And the software display stress, and we'll add another 3D plot and add surface plot of displacement. You can change items into others like stress, strain, or other displacements. And I'll accept the default displacement plot, and I'll plot the displacement plot, and I'll make it deformed. And also for the numerical value, I'll add a point evaluation and choose this point and evaluate. And this will give me the numerical value of the displacement at the left end of the beam. So this was 0.213, and it is correct in accordance with the theoretical value. So now we'll start to build an app. Before we do that, we better save the procedure. And then this is the icon that we toggled between model and app interfaces. So this is an app interface, and this is a model interface. So enter app interface and create a blank form called main form. This is a main interface of the app. I'll create a new form and add the geometry parameters. For this form, I'll call it GEO, geometry. And then create a new form. I'll enter material properties, and I'll name the form material, MTL. Create a new form. I'll select the force or the loading and name the form load. Now add a new form, and I'll enter geometry button, mesh button, and compute button, and also geometry plot, mesh plot. Okay, the name of this page will be preprocessor. And I'll arrange the icons here. And this is the preprocessor interface or form. A final form will be post-processor form. So I'll enter these two icons, buttons, and these two plots, and also I'll add numerical result. Okay, so this is the post-processor form or page. Now I'll arrange these icons or buttons, and this will be the stress plot, and this is the displacement plot, and also the title of displacement plot, numerical value of displacement here. So I will rename this plot by naming it stress plot, and this one a displacement plot. So I can read it from here that it is the displacement plot. So this is the numerical value. So now I finished with the forms. Now I'll go back to main form and insert. First of all, insert a form. The first form will be geometry form. I'll place it here. Insert a second form, the material form, and I'll make it the same width. Insert a third form, loading form. Okay, now I'm going to enter a form collection, and they are pre and post processor forms. Pre, post. And I'll place it here at the right of the interface. So this is the okay, this is here, no problem. I didn't see the numerical value display here. Okay, I finished with definition of the app, and now I'll test the app. This is the app that I have generated. So I'll run the geometry, mesh, compute, and then enter the post processor. Stress plot, displacement plot, and this is the displacement. Now I will change it into 500 millimeter. So I'll go back to preprocessor and define the geometry, generate mesh, and calculate. For post processor, stress plot, displacement plot, and the numerical value of displacement. Now I'll go back and enter 1000 millimeter or a meter long geometry, mesh, compute, post processor, displacement, numerical value. So this app is running okay. So this is the COMSOL app generating steps. It is very useful. For example, in your company you have 10 design personnel and 2 research personnel, and you can get the research personnel to generate an app, and all the 10 CAD people or design personnel can use this app to design the your product. But the CAD people or design people do not have to familiar with the CAE procedures. So you can use this app to expand the CAE result to those people who are not familiar with CAE procedures. So this is a very powerful function in COMSOL, the app generation.